Hey guys, Mr. Brown here, and in this video I thought I would do a few examples of the formal charge resonance structures assignment, which is 2.9 in the Wiley Plus. Hopefully it'll help you guys get a jump on this assignment. So when we click Start Assignment, we go in here and we see an example from our text 2.6, assigning formal charges in resonance structures. So the way this assignment works is they're going to give you a resonance structure with the resonance already drawn, with the arrows already put. You just have to modify the second structure to represent the result of that resonance action. So we're going to assume that the first structure they give us is correct, and then the second structure is incorrect, and we have to modify it for it to be correct. So we'll go down here, we'll look through the example that they give us. I'll let you guys look through that. And I'm going to attempt 2.15a here. So I'll go in here, click Edit Drawing, and take a look and see what we have. I'll try to zoom in a little bit for you. Makes it a little bit easier. All right, so if we're looking at this, so what they're saying is this structure here is correct and it's showing a legal resonance move, and you need to modify this structure to represent that what the result of that resonance move is. So we see the bottom of the arrow on a bond moving to another bond. So what we're showing there is the movement of a pi bond from one location to another. So I will first, so what happens is that turns into just a single bond, and that turns into a double bond. We're not done because we need to consider the formal charges, what happens when that takes place. So we'll notice in the original structure we have 2 carbons here and 2 carbons here, and then there should be only 1 carbon on this one, I said that all wrong. 2 hydrogens here, 2 hydrogens here, and then this carbon has a hydrogen because it's only shown with 3 bonds and no formal charge, so there is 1 hydrogen there. So when we move the pi bond over, hydrogens don't change. I know they have in the picture here, but that's because of the way this system treats formal charges. It numbers hydrogens by the formal charge that you place on there. So we need to fix the formal charge to have the correct numbers of hydrogens, and that really kind of helps us answer the questions in a way. To have a positive formal charge, or to have a neutral formal charge, a carbon would have 4 bonds. And in this case, this carbon that we had here has 2 hydrogens, and now he has 2 bonds, so he should have a neutral formal charge. He's currently shown with a positive, so to change that, I'm going to click the negative button over here and use that negative to take that positive away, essentially. And then now it knows it's got 2 hydrogens there, so that's correct. The formal charge, because a bond left here, and this was a 2 hydrogen carbon to begin with, this should still be a 2 hydrogen carbon now. To represent that, that would be a 3 bond carbon with no lone pairs. It would have a positive formal charge, and if I put the positive formal charge there, it shows the correct number of hydrogens. So I believe this is the correct answer to example A. I'm going to click Save and Close, Submit Answer, and it looks like I am correct. I'm going to go down here and choose another one. I'll pick E randomly and attempt this one. So if I look here, I find I have a ring structure, a benzene. This is a molecule known as phenol, in fact. A phenol with some resonance arrows, more than 1 resonance arrow is drawn. So I see this resonance action here where I move a lone pair down into a pi bond. A pi bond from one position to another, and then a final pi bond being moved from between 2 carbons onto one ultimately receiving carbon. So I'll take the bonds first, or I'll take the bonds first and do the formal charges afterwards. So I see a new pi bond is formed here, so I'll put a new pi bond here. This pi bond leaves, and so this is now a single bond. Reforms here, so this is a double bond. This pi bond leaves and becomes a lone pair on that final carbon. All right, so I've taken care of the arrows, but I need to get the formal charges correct. So this lone pair moved into a double bond or a pi bond position with the carbon, But we have to keep in mind the hydrogen did not leave. That doesn't happen in resonance actions. No atoms change. So the hydrogen did not leave, even though it's not shown over here yet. You would have an oxygen with one lone pair, because that lone pair left to be a pi bond, and 3 bonds, 2 to the carbon and 1 to the hydrogen. So it would have a positive formal charge, and indeed, if we put the positive formal charge there, the hydrogen appears. So we want to also keep in mind that formal charge, overall net formal charge, should never change during a resonance action. So when I go from a neutral molecule here to one with charges over here, all of those charges must cancel out. So where does the negative formal charge go? Well, it should probably go on this carbon here with the lone pair of electrons, considering before we showed the resonance, this carbon was shown with no formal charge. So that means it has 1, 2, 3 bonds. That means there had to be a bond to hydrogen here. So now that we've completed the resonance action, we have 1, 2 bonds to carbon. The third implicit hydrogen is still there for a third bond, plus 1 lone pair of electrons makes this a carbanion. So we're going to show it with a negative formal charge, just like that. And I believe this is the correct answer for example E. Click Save and Close. Submit answer to check ourselves. We get the green box. So that's the example for example E. I hope this helps you get a head start on this assignment. Please let me know if you'd like to see some other ones work. Give me an email if there's one that's giving you particularly a hard time.